Okay, we're going to be talking about oxidation and reduction of ketones and aldehydes. Now, before we get into this, I want to discuss about a technique that I use to help me to remember how to go through this process. Okay, so what I like to use is this. Okay, just remember, Leo the lion says grr. Alright, so how do we use this? So this helps us to remember that we lose electrons during oxidation, and we gain electrons during reduction. Okay, so every time we use oxidation, we lose electrons. Every time we use reduction, we gain electrons. So I hope that this will be helpful for you during this whole video and during your exams and quizzes. We're going to be oxidizing alcohols. Alright, so we have here a primary alcohol. This one means that it's primary. And if we use PCC, we end up with this structure here, which is an aldehyde. Now, the question is, how do we get this structure to end up looking like this, an alcohol to an aldehyde? So that's the question. So here's how we do it. Okay, so what I like to do is I like to start out with a structure from this here. Okay, remember, this is a carbon. Okay, this point here is a carbon, so it has two hydrogens. Now, what I like to do is I like to make this a double bond. This would mean that this would lose an electron, removing the H. And as we discussed earlier, okay, Leo the lion says grr. During, well, we lose electrons during oxidation. And we're doing oxidation, so we lose an electron. And then since we have a double bond here, we have to remove this. And so we have a similar structure to these two. And that's how I kind of imagine this in my head. Okay, let's try another one. Our second one. We're going to be using another alcohol. This time it's a secondary alcohol, and we're going to use PCC again. And the result of this would give us a structure that looks like this. And this structure, of course, is a ketone. Again, how do we get this structure from here? I'll show you what I do. So if we're going to write this out this way, okay, we can say that this is the same as this, because here is the carbon. Now remember, every carbon has 4 hydrogen bonds. So even though we didn't write it here, it's actually there. So here, we're gonna double bond the oxygen. And we have to lose an electron here, so we cancel this out. And this has now 5 hydrogen bonds. 1, 2, 3, 4, 5. And we only need 4. So then we have to remove this. So that leaves us with a structure that is similar to the results here, which gives us a ketone. Okay, let's try an example. So we have this structure here. We have an alcohol here and another alcohol here. This is secondary, primary. So the structure is a secondary alcohol. And when we react it with PCC, what do we get? Okay, let's try. Okay, so what do? Now remember, when we oxidize, we lose electrons. So Just double bond. Also double bond. We lose. We lose. So remember, this is a what? Carbon and a carbon. This carbon has 1, 2, 3, 4. Okay. This carbon has 1, 2, 3. We need one more. H. And this is the result. Okay. Let's try now reduction of aldehyde. Now remember, during reduction, what do we do? Let me find my paper. Here you go. So during reduction, let me zoom out, zoom out, zoom out. So during reduction, we gain electrons. Remember, Leo the lion goes grrr. So during reduction, we gain electrons. Now let's utilize that with this problem. Okay. So let's try to write this out over here. Okay, so we have our CH3. Okay. Okay. Now, with reduction, what we're basically doing is kind of doing the opposite of what we did with oxidation. So now we're going to be distributing these two H's here. How do we do it? Okay, so let's add this H. And let's add another H here, hydrogen. And let's compare. Now, as you can see, when we added the H, we have to remove one of the bonds, right? So it's just like the opposite of aldehydes, where, opposite with oxidation. With oxidation, we add another bond to the oxygen. Here, we remove it and add the oxygen next to the oxygen. We add a hydrogen next to the oxygen. Sorry, it's like 2 a.m. I'm kind of sleepy. Anyways, this is it. This is the structure. So we have an ethanol here, and this leaves us with ethanol. Right. Okay, let's try another one. Oh, it's a little blurry. Wait. Okay. Alright, let's try the structure here. Okay, now we're gonna be reducing this ketone of a, okay. The first thing we notice is that there's a double bond to the O, and that we need to distribute these two hydrogens. Alright, let's keep that in mind. Let's write out the structure here. Okay, as you can see here, we have a double bond connected to the oxygen. Here, we're going to be doing reduction, and remember, during reduction, okay, we gain electrons. So this oxygen is going to gain a hydrogen, meaning it would lose one of the hydrogen bonds here. So how do we complete this? We only have 3 bonds connected to this carbon. We should have 4. So let's add another one here. Anyways, we need 2 more because we're going to be adding 2. So this is your structure. This would make it 2 propanol, or it would actually look like this. 2-propanol. Alright, here's an example of a reduction test, which is called reduction of Fehling solution. Reduction of Fehling solution, which consists of a complex of copper 2 sulfate and alkaline sodium potassium tartrate solution by glucose to form a precipitate of copper 1 oxide. Glucose is oxidized to gluconic acid. This reaction is used as a test for aliphatic aldehydes. Okay, this is a video depicting a reduction of Tollens reagent and ammoniacal silver nitrate complex by glucose solution to form silver mirror. Glucose is oxidized to gluconic acid. This reaction is used as a test for aldehyde groups in organic chemicals, which includes formaldehyde, acetaldehyde, and glucose.